Good evening, everyone. Welcome to the first workshop of Algoarena, organized by the Leo Club of the University of Sri Chavarathanapura in collaboration with the IEEE Student Branch and the Computer Society chapter. I am Dinati Tarindi, and I will be your host for today's meeting. We are so glad to have you all joining us for this exciting and informative evening. And also, we have a quick announcement for everyone. We are thrilled to let you know that every participant who takes part in throughout this workshop series will receive an e-certificate for their participation. To get yours, all you need to do is fill out the Google form that will be shared during each session. So make sure to pay attention and complete the form when prompted to secure a certificate. Before we begin, let me give you a quick idea about Algoarena. This is an inter-university coding competition organized by the Leo Club of the University of Sri Jawaharlal in collaboration with the IEEE Computer Society. It consists of two rounds, an online preliminary round and a physical final round, along with a series of skill-building workshops like this one. The project also gives a platform to showcase Leo Club projects across Sri Lanka, encouraging learning, collaboration, and leadership among students. Now it is time to move on to the main part of today's session. We are really excited to have with us Mr. Suresh Peiris, the co-founder and the director at InfoWells and a community leader at GTG Sri Lanka. He will be guiding us through today's topic, APIs, databases, and cloud integration, and sharing his valuable insights and experiences with us. So without further delay, let's welcome Mr. Suresh Peiris. Sir, over to you.
Hi, very good evening to all of you. Hope I'm audible. Can someone please confirm whether I'm audible?
Yes, sir.
All right, okay. So first of all, thank you very much for having me in this workshop and pleasure to share my knowledge in the inaugural session that you all are having in parallel to this conversation. So let me give a brief introduction about myself before I begin. My name is Suresh. As the introduction, and I'm a co-founder of Infowaves and Articom. Let me tell what we do at Articom and Infowaves. Basically, we are one of the leading generative AI businesses in Sri Lanka, helping businesses to automate their processes with generative AI. So that's what we mostly do. So we are working with a lot of technologies, including Google Cloud, Azure, and there are so many other technologies we're working with. So that's a very nutshell idea about what we do, but there are so many things we're working with. So apart from that, I'm one of the community leads of GDG Sri Lanka, or we can call it as the Google Developer Group Sri Lanka. So yeah, that's a bit about myself. So during this workshop, I'm planning to talk about several things. One thing is that the APIs. So the main topic for the day is about APIs. So not only APIs, we are going to discuss about different databases, as well as we are going to talk about how we could do the integration between APIs and databases, as well as the usage of mobile application development integration toolkits. So we are going to discuss about more aspects. First of all, we are going to learn about what APIs are and how to, what sort of different system architectures do we have. That's one thing. And then we are going to talk about different database types. And also we are going to talk about how we can integrate all together. So apart from this, I thought of talking a bit about like content, headless content management systems as well. For an example, Strapi and Contentful. So during this competition, I'm pretty sure if you want to build application rapidly, this is going to be pretty much helpful. So I'm pretty sure, yeah, you can build scalable applications with the use of all of these technologies that I'll be mentioning throughout my entire session. Right. So before I begin, I want to have a small uh, feedback from all of you. Can I know how many of you are beginners to API development or backend development? Can I see a raise of hands? I just want to get the count. Um, you can raise your hands on Zoom. Okay. Right. Okay. I see. I see. Right. So can I know? Okay, you guys can put your hands down for the next set of questions. Right. Thank you very much. Can I know how many who are intermediates, those who have built at least one API before, and those who are seeking guidance for next step? Right. One hand. Okay. Right. Right. So I guess the majority are beginners here. So I wanted to make it beginner friendly as well, in a way that everyone understands. And I'm going through certain concepts that are there for API planning and API development. So yeah, so let's get things started. Thank you very much for the feedback. Right. So first of all, before I dive into the rest of the topics, let me talk about what is an API. So just imagine you are going to restaurant, right? Just imagine you are going to restaurant and you are seated at a table, right? And then you want to order some food. What do you do is basically, you are first of all, you are calling a waiter and then you are giving the order, right? For an example, let's say if you go to a buffet like a hotel, maybe Shangri-La, or a restaurant, or let's say KFC, right? You just sit on the table and then the waiter comes to you and then you are saying, okay, I want this. And then waiter goes to the kitchen and the waiter is supposed to hand over the order to the kitchen staff and they will prepare and they will give it to you. So what I want to say is basically, if you go to a restaurant and can you directly go and talk to the kitchen and say, I want a chicken bucket? No, right? Because it has to be done in a way that, first of all, we are talking to the waiter, and then waiter goes and waiter talks to the kitchen, and that's how the order is fulfilled. So similar to that, right? In application development, in any application development, maybe mobile applications, maybe websites, maybe any sort of other frameworks, we have way of retrieving data. See, for an example, just imagine you are building an application such as Instagram, right? So if you take Instagram, there are several operations. For an example, starting off with the very initial level operation, which is a login feature. What you do is basically you enter your username and password, and then you press login, and automatically the login request is fulfilled, right? But if you take that operation, it's not always the front end who is communicating with the backend, right? So backend is separate actually. Backend is there with all user information and username and password. Backend is there, but the front end never talks to the backend, sorry, the database directly, right? There has to be an intermediate layer. So this intermediate layer is known as the API, Application Programming Interface, because we can't straight away call the request from the front end to back end, right? There are ways of doing that, but let's talk about the pros and cons of doing that during the session. So let's try to understand, okay, what are the negative points and what are the plus points of having a third party backend that gives you the logic that you wanted. Right. So let's get things started. So first of all, I have few technical terms to note. One thing is that we have something called client, we have something called API, we have something called server. So let's try to understand these technical terms because I'll be using these technical terms multiple times in my session. So I'm pretty sure these are going to be helpful. Yeah. So first thing is the client, right? See, for an example, if you are building an application, we have something called presentation layer, which is more like a user interface that we see content in real life, right? Which is called a presentation layer. So this could be something like a mobile application front end. This could be a Flutter front end. This could be a React Native front end. This could be a React front end, Next.js front end. So the front end can be built with any framework we wanted, right? So we call it as the presentation layer, which is basically the way of representing data. It's more like a outfit, right? So we can design this presentation layer or the front end with any of the stylings, right? We can use any kind of styling kits, CSS, right? Even different types of UI components. We can build a very appealing kind of a UI where the clients can see and where the clients can interact with. So that is number one. And then number two is the API. So API is more like the waiter, right? So if I go back to my previous example of the restaurant, API, the waiter can be known as the API, right? API is where the front end, which is you, who requests for information, requests for requests. See, for an example, waiter comes to you and you say, okay, I want this food. And waiter goes to the kitchen and waiter hands over the order to the kitchen staff and they deliver. And then waiter again takes the order and comes to your table and then settle the order. Just like that, API is also a transport layer, right? So you have the front end calls for backend resources through the API. So API is more like a transport layer we have in between the front end and the back end. It's more like a bridging layer, right? So basically these APIs can be written with a lot of frameworks. So we have something called Python Flask. We have something called Node.js and Node.js Express, and there's something called Nest.js. So we'll look at different API development frameworks throughout the whole session, and there are so many frameworks available. We'll see different frameworks, but we have a Python Flask-based example as well. So during this, you will learn about Python Flask as well as multiple other frameworks. So let's go through that. And finally, we have another component, which is known as the server or the backend, right? This is where all the logic is being processed, right? See, for an example, if I go back to my previous example of Instagram, where you have to log in to a certain account, what you have to do is you have to provide the username and the password together, right? And then before that, before the screen, there's going to be a massive logic that is being processed from the backend itself. Okay, it will talk to the database, it will send request, it will ask check, okay, your account is there, your username and password is correct, your account is not blocked, right? So all of these logical operations are done in the layer of backend. So we are using frameworks such as Python, Python Flask, Node.js, and all of these frameworks to build the layers of a server and the API. Right. So these are the technical terms and all. So we'll discuss about this in detail because we have long agenda, and I don't want to spend much time about on explaining these terms and terms because um, it might be boring. So let's move forward. Right. So one thing is that why APIs are important, because this is one of the questions and a lot of people are thinking, okay, you all might have worked with frameworks such as Firebase, right? Because if you have something like Firebase, we can do a very easy integration with the mobile application and you can get it done. There's something called Firebase real-time database or Firebase Firestore that we can straight away connect to applications and we can get things done. So a lot of people are asking when I'm conducting workshops, why don't we straight away integrate Firebase with mobile applications? Why don't we directly integrate Firebase with web applications? That's a good question, though. So the answer that I have in hand is that, okay, you can do that. Technically, you can do that. That works. It's a direct communication without having any sort of a backend or API. It's a direct communication with a database. But just imagine we are building a system that scales up to millions of users. For an example, just imagine the Instagram scenario once again, right? So Instagram has a mobile application and Instagram has a web application, right? Which we can both log in from either computer or mobile phone. So just imagine it's being connected to a database straight away, right? So you have a mobile application of Instagram and then you have mobile application of, the website of Instagram. Just imagine both are being connected to the Firebase database directly. What would happen? Just imagine if there's any sort of a logic change that is supposed to be there. Let's say the admin decides to deactivate all the accounts. or the admin decides to, make a change to the account policies. In that scenario, the change has to be done in both application side and the website end as well. So that's the main concern, right? See, if you want to like distribute this, if you want to centralize this logic, the perfect way of centralizing the whole process is through a backend, right? Because if you have a single backend, if you have a single API service that straight away sends the information to both website and the mobile application, that issue won't be there anymore, right? Because you have a central layer of communicating with either the backend or the front end. You don't have to worry about that. So that part is sorted. Number two is the safety, right? So just imagine you are straight away connecting like a Firebase database or Superbase connection or something like that straight away with a mobile application once again. There's going to be a massive security issue, right? Because see, these are being handled from the front end side. That means your communication protocols are being exposed to public, right? So even the authentication protocols, even the authentication mechanisms are being exposed to public. They can simply view the source code. They can simply right click on the web page and view source, and they can find the whole source code and the authentication login, the logic of your application. So even if your application is written with React or some other framework, some other JS-based framework, this is possible, right? They can easily inspect element and find all the application authentication logics. They can find the Firebase keys, and every single thing is being publicly visible. So because of that, it's going to be 100% possible to find out the confidential informations and gather the data from Firebase or whatever the framework you name it. So that is a reason why we don't directly integrate with the front end and the database service straight away. There's a reason. That's why we have an intermediate layer called the backend, which is known as the API, right? API is more like a language. So we'll talk about that. Right. So now I was using multiple technical terms like backend, front end, and multiple other technical terms as well. So now you all might be wondering, okay, so I mentioned about two things, API and the backend. So I mentioned that, okay, these backends are built with multiple frameworks. For an example, Python Flask, Node.js, or Java Spring Boot. And there are so many other frameworks that you can use to build these backend services. But if you build a backend service, let's say you're building something with JavaScript, right? And then your front end is done with something like let's say Flutter, right? So you have Flutter application and your backend is done with, let's say, JavaScript. How can you connect these together, right? Because these are like two different programming languages, right? How do you connect JavaScript with Flutter Dart? Is that possible? Yes, that is possible, right? So just imagine you're talking to a foreigner, right? Just imagine you're talking to a foreigner, maybe a foreigner from, let's say you're talking to someone from the Asian region, maybe someone from Singapore, or maybe someone from, let's say, Malaysia, right? Can you talk in their own language? We can't, right? Because we don't know their language. That is why we have something called English, right? That everyone understands. I understand, and even the Malaysian person would understand English. Just like that, we have a common method, we have a common approach, common way of communicating the backends and the frontends together in a common language. So these languages are called as JSON and XML, right? So these are very common languages that most of these APIs are built. It's more like an interface. So as you can see, the definition of API itself is application programming interface. It's an interface. So regardless of whatever the frameworks your applications are built with, at the end, the communication happens, right? The communication happens via this language called JSON or XML, right? So nowadays, XML is not being used because there is being used in all the frameworks that were using this concept called SOAP. So now XML is not being used. So I won't be talking much about it because it's outdated. So I'll be talking about JSON which is one of the most popular languages of writing markup scripts and representing data. And you can bridge the gap between the front end and the back end together if you use something like JSON, which is one of the greatest languages, one of the greatest data modeling languages. It's not a programming language. It's called a data modeling language to be used to bridge the communication gap between the front end and the back end. So that is the beauty of using something like JSON. Right. So let's talk about JSON now. How does it understand the common, how does it being structured, right? So as you can see, this is how the JSON scripts are being formatted, right? So when it comes to JSON structures, right, we don't have a right or wrong way of defining the JSON structure, right? But we have to always adhere to the syntaxes of JSON. Syntaxes means, okay, how do you define these semicolons? Not semicolons, sorry, the curly braces, and how do you put these double quotes, and how do you utilize this sort of a colon and then commas, right? There's a particular syntax we should always use. Syntax is basically like a grammar, right? So when you're speaking in English or when you're speaking any other language, we have something called grammar, right? So just like that, for JSON also, we have something called JSON syntax that we should always follow. So let me talk about the JSON syntax here, basically. So when talking about JSON, we should always start with this sort of a curly brace, and also we should end with the curly brace also. That is a must. And then if you are defining some sort of a key means basically it's more like an identifier for the field, right? See, for an example, in this JSON request, there are multiple fields, right? There's some field called name, email, age, address, and street, city, state, zip. So these are all fields. So if you want to identify a field in JSON, you can have like double quotes and then colon, and that's a field. And then to define the value also, in front of the field, you can just define add double quotes, and then you can add whatever the value right in front of the field. So then that is how you can define a JSON object. So basically there's no proper structure to this. Basically you can structure this data in any format you wanted. There's no right or wrong way, but there are syntaxes. Like I mentioned, we have to follow the syntaxes. So if you guys want to learn about these syntaxes, you can just go to Google and search for JSON syntax, and just go to the W3 Schools has a really great syntax guideline that you all can refer to. And they have given a really good guideline on how you can structure this data for backend communication. And see, just like this, there are so many concepts. So I would recommend you all to go through this W3 Schools guideline for JSON syntax, which is really good, so that you all can get things started with this. All right. So moving forward with XML, so I won't be talking much about XML though, because it's outdated language. So this is also one of the other markup languages which was there, and even HTML is also based on XML. It's a markup language. That means we can define the structure and we can put the data, and the representation can be done just like this, right? So as you can see, the same data are being represented in both XML and JSON. So as you can see the difference, in JSON it's a totally different structure, and in XML it's another structure, right? So just like that, you can see the same data has been represented in both formats. All right, so let's dive into the technical aspect on how these APIs are working. So as you can see, this is how the overall workflow works. So basically these us, right? So as you can see, these are the users. And then imagine you have an application that has both mobile app and the web app or a desktop app, right? And then we had to retrieve some information straight away from the database. Let's say you are doing some sort of login operation. Let's say you are doing some sort of a content upload, maybe a content retrieval. So for those operations, we need to request the data from user send from the database. So what happens is basically users are there, basically they are connected to the internet actually. And then first things they do is they make a request. Just imagine this mobile application is built with Flutter, and assume the desktop application is built with React or Angular or some other framework. So what happens is, from this particular application level, it's going to make a request, right? Just like that waiter thing, it's going to make a request from the server. So, so server has to respond to the request basically. So it's going to make the request as as a JSON data. See, for an example, let's say if it's a login request, along with the login request, the user has to send the username and the password all together. And then the backend has to understand the login request, and then it should check the credentials from the database, whether the user is there in the database, maybe as a MySQL query, maybe as a Postgres query. So depending on the database type the application is having, the server is supposed to query for the data and then get the data back to the server and then pass the data back to user as a JSON. See, so in this flow, both data inputting and the outputting is done through JSON format, right? So JSON is the universal language that are being used in APIs to communicate as well as to provide this data back to the users and collect from the user as well as send this data back to the users. JSON is being the most popular language that are being used nowadays in a lot of applications. Same goes to the desktop application also. For any request, it's going to go through the server, and server is the one who is going to operate the logical part of it and then get the data from the database and then send it as a JSON through the application programming interface, or we can call it as the API. So that is the overall flow of how it works. And let's try to properly understand a practical scenario. Right. So we have given another example here. So as you can see, it says get request to a, okay. So it says get request to a weather API to retrieve current weather, right? So this is actually another benefit of using an API. See, for an example, you guys could be building your own backend services, but let's say you all want to have some additional capabilities. So for an example, let's say you wanted to build an application that interacts with some sort of weather API. Or maybe, let's say you want to build an application that takes maybe the geocodes information, maybe that, you know, converts some data into different format, maybe an AI application, maybe AI chatbot or something like that, right? So these capabilities are external, right? Because you are not the one who's building these. So all of these API capabilities, all of these, different types of behaviors of using these APIs could be external. So because of that, we really have to think, okay, how should I integrate that? So these APIs are not there only to work with your own backend, right? So you can talk to different third-party services, and you can talk to different third-party APIs, maybe AI services, maybe good mapping services, maybe locating services, right? Any sort of service, and then at the end, you can pass the data. So that's what you should do basically using architecture like this. That is the advantage. Right. Okay. So let's talk about different methods, different API methods we have in hand. So we have four main methods, but there are other methods as well. When it comes to APIs, there are four main methods. For an example, get, post, put, delete. So these are all CRUD operations. CRUD means create, create, read, update, delete. So for an example, let's say you are building some sort of a HR system, right? So, and then what are the operations you all should perform? You should be able to get some information about a person. You should be able to, add a new person. You should be able to update a person, and you should be able to remove a person from the system. So for those sort of scenarios, you can build different API endpoints that are handling particular tasks. So I mentioned a new term right here for the beginners who are freshly into backend development. I'm sure that this could be a bit more technical, so I'll try to break it down into a less complicated way. Right. So just imagine. Let me go back to the previous the same example I mentioned, which with regard to building an HR system. So in this sort of system, when you're building a backend, we have another concept called backend endpoints, right? So when you're building a backend, we have something called backend endpoints, which is more like a identifier for your data, right? So in this sort of scenario, we can see there are four endpoints. We have something called get person endpoint. We have something called post person endpoint. There's something called put person, and there's something called delete endpoint. So these are four different endpoints we have with regard to the backend. But as you can see, these are there are four different methods, right? There's something called get, post, put, delete, right? So it doesn't make any difference, even though we use a post endpoint to get some information, even though we use a get endpoint to add some information, it doesn't make a big difference. But why does it matter? It's more like an identifier to properly label your capabilities. Just imagine a system with like very mixed type of API methods. And let's say you're using a get method to add person. You're using a post method to retrieve information. That sort of a labeling would make it more disorganized, right? But if you want to make sure your system is well organized and APIs are well safe and the APIs are well organized, make sure you properly label your API methods. In that way, anyone who's going to be doing the integration is going to understand your requirements, and it's going to properly, you know, understandable by anyone who's going to do the integration, and the code quality is going to be pretty much higher if you have a proper labeling of these methods. Right, so let's talk about more endpoints we have. For an example, these are like some other endpoints that are possible. See, for an example, in this scenario, we have another few more endpoints. We have something called user endpoint. We have something called products endpoint, right? So these endpoints can be architected, or these endpoints can be added in the way you wanted, right? There's no right or wrong way of naming these endpoints, right? Because you can put any name for these endpoints, and you can define any of these endpoints the way you want it, right? So if you want to add some data, delete some data, you can have different endpoints to match a different purpose, right? So yeah, so let me show you one more thing. Just give me a second. Let me go back to my demonstration. Yeah, sorry about that. Yeah, so so in this example, as you can see, these three endpoints, right? These four endpoints actually get, put, delete, and the last one. So these three endpoints and the last one, you can see there's something called ID, right? So there's a way of naming these endpoints actually. So you can for the naming for the text, you can actually put anything. So if it's a user, but make sure you put something meaningful over there. But let's say this sort of endpoint, let's say if you want to get all the users, you can just have endpoint call /user to get all the users. And also to add a new user, you can have just like an endpoint like post /user. If you want to add a individual user. And then if you want to get a specific user by the user ID, right? So you provide the user ID, and then if you want to get the data of that particular user only, you can have an endpoint like this that you define. And then the moment you pass the user ID, you should be able to get the individual user's user information by calling this endpoint. That is another possibility. And then if you want to update a particular user by the user ID also, you can have an endpoint like this, where you can call and where you can do the updates very easily. And same goes to deletion. And these how you can actually construct these endpoints in a proper way. And I'll at the end I'll give you some tips on how to document these properly, as well as what sort of API documentation tools that you all can use to arrange this API. So I have a lot of other examples also. So yeah, I'll show you at the end of the presentation. Right. So now moving forward, we have different types of, so now we have a understanding about different types of APIs, what is an endpoint, and what does it do, and what sort of different methods we have in these APIs. So not only these, there are more actually, not only these things, there are so many other endpoint types, and let's try to understand what sort of other types we have. But let's get things begin with this, and then later on, we try to understand the rest of the other APIs also. Right. So now let's talk about different types of architectural tiers. One thing is that we have something called one-tier architecture. This is actually one of the old ways of representing information and representing data, right? This is the architecture tier that I mentioned in my first example, that you're connecting your application directly with Firebase, right? See, we have the database over here. And then this could be your application, this could be your website, or this could be anything. And you are straight away communicating with the database. So like I mentioned earlier, there are so many negatives of this, of doing it like this, because you don't have intermediate layer, right? So if you want to replicate logic, if you want to replicate some sort of login handling or account management or something like that, you have to replicate the same process, the same logic in every single application, right? Because there's no intermediate layer. If you are talking to intermediate layer, then you can introduce that logic in the intermediate layer as the middleman, and the middleman can deliver whatever the request based on that. So you can, in that way, you have to change onto the middleman. So the middleman can do the delivery from the database to the client. But these are the negatives of having a one-tier architecture, because the logic has to be implemented in every single application. And if you want to make a logical change to the application, you have to release an update, right? So we should really think about, okay, how to avoid updates, right? So in that sort of scenario, if you're looking at how to avoid these updates, I would not recommend, if you want to avoid updates, I would not recommend using a one-tier architecture, because for every single bug fix, you have released an update if you have a one-tier architecture. Right. And then we have something called two-tier architecture. So two-tier architecture is basically you have an additional tier. So you have the client, right? So you have something called client tier basically. So the client is going to be fetching the information, and it's still the UI is going to directly interact with the database. So in this one tier architecture, what's happening is the device is going to be straight away talking to the database, right? In the client tier, in the two-tier architecture, what's happening is basically there's going to be a front end. So there could be like a website, there could be a React Native application, there could be a Flutter application. So the user is having access to application, and the application would talk to the database. But that's still risky, right? Same issue could happen because we don't have a backend, right? So even if we have to release a fix, you have to update all the applications. You have to update every single client, right? So still that could be very risky. So that's why we don't encourage using one tier or two tier. Instead of doing that, we recommend the three-tier architecture. So in three-tier architecture, we don't have that sort of issues, because we have the client computer talking to the application server and application service talking to the database. So in that case, let's say we have a critical bug fix to be done. So in that scenario, we had to update only the application server only, right? There wouldn't be any sort of a update required for the client, because whenever the application service being updated, automatically that applies to all the clients. We don't have to worry about that. So straight away from the application layer, from the application server, we can handle the update, and that rolls out to all the users. So we don't have to worry about the logical tier basically. And safety wise also, this is more convenient, and it's really safe. So we don't have to worry about any other thing if you're using this sort of a architecture. And nowadays, we are working with the era of microservices, right? So now one-tier architecture, two-tier architecture, three-tier architecture is outdated. But still, we are using the 3D architecture as well. But still, even though I use this term called outdated, it's not outdated. Still, people are using that for different business cases. So we can't really call it as outdated, because there are certain business scenarios applicable to these architecture types. So we can't really call it as outdated, even though I used it previously. So in the modern day world, we are here. So we are in the NT architecture, which is known as the microservices. So what happens is basically This is us, this is the client, and maybe this could be a React application, this could be a Flutter application. We are here, right? Imagine there are millions of users who are connected to your application, right? Not just like 10 users, not just like 100 users. There are millions of users who are using your application. In that case, just imagine if all of these millions users connect to a single server, what's going to happen, right? So I'll take a basic example for this. So I know that all of you have gone through the A levels. No? So during A levels, what's going to happen is basically you are logging into the departments of examination server, and the moment you log in, you can see it takes a very long time to load the results, right? Sometimes the website completely crashed. So in that case, we can't see the results at all until you take like a long break and then come back and check the results. Why? What's the reason? Because of the scaling aspect has not been taken into consideration when designing these sort of systems, right? So to handle the scaling part, there are so many technologies that are being used in the modern day world. We have something called Kubernetes, or we can call it as the K8s to handle the scaling. And we have different scaling mechanisms called vertical scaling, horizontal scaling, right? So depending on the demand, the system scales up. If whenever the load is high, there will be more resources available. When the load is low, again, the system will be made smaller. So that is called the scaling, right? To handle the scaling, there's something called load balancer. So load balance is basically like the intermediate service that takes the web traffic, that takes the entire web traffic and then directs the request into the correct machine to the correct replica, where where the size can be scaled up or down, right? So if the system is designed in that way, if the system is designed in a way that it can scale up or down, we really don't have to worry about looking at the infra when the traffic is very high. Automatically, the infrastructure, the servers would scale up and down depending on the volume of traffic that you are having. Right. So now going back to my main topic of NT architecture. So it's more like a architecture that comprises of multiple services, or we can call it as microservices, right? Just imagine Uber, right? So I believe all of you are using Uber or PickMe, right? So if you take a taxi application like that, just imagine um, there's an error when sending the email, right? Maybe the email quota has been exceeded, maybe the email service down or something like that happens. If the backend has been developed as a single source code, what's going to happen? So even if there's a single failure of sending an email to a user, the whole backend is going to shut down. Why? Because all the services are in a central place, right? All the services are in central place. So even for even for booking a ride, even for making a payment, even for doing some sort of the operation, every single operation would fail because of a one single point of a error, right? So error could be in the email also. So it could be anything, right? But we have a new architecture that people are looking at these days. It's called the microservices architecture that we distribute the logic, right? So let's say we have one service to handle the emails, one service to handle the ride booking, one service to handle the payments, one service to handle the mapping, right? So we can distribute these sort of services to match some sort of system requirement. So in this sort of architecture, even if the email service is down, it won't affect any of the backend components. The central backend would work as expected. So we don't really have to worry about, okay, the system is going down because the microservice architecture is decentralized, and we don't have to worry about one service going down. So only that particular feature won't work, but the rest of the backend would operate normally, right? So that is the beauty of having an NT architecture. So we distribute the services, and then the backend server would talk to the database, and it's very organized. So I would recommend, if you are building any sort of a scalable applications, you can always go with the multi-tier architecture, or we can call it as NT architecture, or we can call it as a microservices architecture. So it's really good. it's a really good architectural framework that you all can use. Right. So we all discussed about this on how these users are talking to the databases. So we had users, and then we had the mobile phones and desktops and internet. It's talking to through the internet, and then you have the API, right? So API is actually carrying data as JSON, right? So it's more like English, right? So English to all these applications, because there has to be a single point of communication between the server and the users. So JSON is the common and shared language between the servers and the users, and sorry, the servers and the front-end applications. So it's more like a shared way of communication, even though you're utilizing different programming languages to build these front ends and the back ends. You don't have to worry because it's been handled through the API as a universal form. Right. So without further ado, let's get things started, right? So I think we already discussed about multiple things here. Okay, the APIs in 3D architecture. We have the client tier and the application tier. So we are actually talking about this architecture because we are, like I mentioned before, we are going to ignore the 1T architecture and the 2T architecture, and we are going to consider only about the 3T architecture from now onwards. Right. So now you can see we have three layers actually. We have something called the client tier, and here's something called the application tier and the data tier, right? So client tier is basically how you represent the data. So this could be any application, this could be React or Flutter or any sort of other framework. So I think I already discussed about it. And then in nutshell, I'll quickly go through it, and then we can go for a practical demonstration. And we have many things to discuss. So I will quickly go through it, and then we'll come back to it later if the time permits. And then we have the application tier, which is basically like the backend, uh, basically. So that processes all the information, the logic and everything, and then communicates data between the client and data tier. So that is the application. And then finally, we have the data tier, basically. So adding a small comment on the data tier, there are so many databases you all can use for this, right? It could be a MySQL database, it could be a Postgres database, it could be a MongoDB. So let me share a small insight here. So a lot of people are asking me, so I know there are so many databases. We have something called Firebase, we have something called MongoDB, Postgres, MySQL. How do I choose one if you're building an application? Is it based on your familiarity? Is it based on something more popular? Is it based on something different? No, so there's an answer for this basically, right? So for an example, think about applications that you wanted to query some data. For an example, let's say you want to build some sort of a complicated reporting, you want to query some complicated data reports. Let's say if you want to get some like scalable data, right? So when decide if, let's say, like I said, to get the reports in a more advanced way, I would say going for a MySQL or a Postgres would be fine because these are relational databases. We can actually execute queries. And then imagine you're building something like a chat application or a chatbot. So in the chatbot, if you want to store all the messages in a databases, in the database, you can go for a database like MongoDB. So MongoDB is actually NoSQL kind of database. NoSQL means it's not using any sort of relational strategies. It's very scalable though, right? Even though you have like millions of records, even though you have like very large number of scalable records, you don't have to worry because MongoDB will take care of that. So I would recommend if you are building an application that would like that has so much of exponential data values. If your database is exponentially growing, I would say go for a MySQL database. So I'll share my one of my personal experiences. So recently we were working on a project for a client, and the project was building a ticketing platform, e-ticketing platform for for a company. And then they asked us, okay, what are the databases are you using? So we said, okay, we are using MongoDB and Postgres. So they ask us why? Why can't you stick to one database, right? If it's like ticketing, I mean, even if you stick to MongoDB, that's fine, right? We said, okay, we can't do that. Why? The main reason is that, especially if you are working with a system like a ticketing platform, we have look at two ends. It's one thing is that we had to work with users' data. One thing is that we had to look at the bookings. One thing is that there's going to be like a massive client operation which is behind the ticketing flow. The other end is that the ticketing flow. When it comes to ticketing flow, these tickets are going to grow rapidly fast, right? For an example, if it's just a one event, if it's like a concert or something like that, they are going to sell somewhere around like 5,000 of tickets, maybe like 10,000, depends on the scale of the concerts. They are going to sell a massive number of tickets. So per day, it's going to be exponentially like increased. So we said, okay, we can't do in two databases. And instead of what we are doing is, okay, we are going to use MongoDB to store the ticket information because it's going to exponentially grow for sure. And then we are storing the user's information as a relational database. So we are using something like Postgres to store the user's information, and to store the ticket information, you are using MongoDB, so that the system would work as expected, right? So in the more scalable way. So that is a question that a lot of clients are asking us. Okay, what is the architectural argument behind some sort of a choice of technology, right? So that is always there. Right. Okay. So, like I said, I think I already explained y'all how it works in 3D architecture. And then we are going to look at, okay, different types of third-party API integrations also throughout the entire session. So I have some practical hands-on code labs also prepared for you. So before we go to something like that, I'll go for a round of questions, and then we'll come back to this and we'll continue the session. So floor is open to all your questions now. I'll quickly come back to the session after the Q&A. So you all can drop your questions in the chat. I'll give you like few minutes, 3 to 4 minutes to drop your questions. So then I'll come back and we can continue the rest. Right. So I got the first question. What is the difference between the database versus the server? Right. Okay. So let me explain this basically, right? So database is more like a place that you can store information, data, right? So basically, database can be anything. Just like there are so many different, database technologies. For an example, MySQL, Postgres, MongoDB. Like I mentioned, there are so many database technologies that are available. So it's how you store the information in different ways, right? It could be in like multiple ways. Basically, it's more like a way to store the information in different representations. But at the end, all of this data, so even though we use different database technologies, all of these data are being stored in a server. Server is actually like a computer, right? So these computers are in cloud. Cloud means, okay, there are different cloud providers, for an example, Google, Microsoft, AWS, Amazon, right? So it's more like a computer that they are renting out. Cloud service more like a computer that these popular cloud service providers are renting out, right? You can actually pay amount, we can pay some amount, and we can rent a space in their cloud service. So maybe $5 or maybe $10, or depending on the scale, you can pay some amount and we can rent a space in their data center. So like I mentioned, these databases can be placed in your own server, Oh, and there's something called managed databases also, where we don't have to worry about the data warehousing, because with the managed services, they will take care of your data. So you just have to connect to the database and add the data. That's it. So that's the main difference. So we can't really compare the database versus server actually, because the database is there in a server itself. Hope that's clear for you. Right. So we have another question. How does microservices or Kubernetes really work? That's a good question, actually. So Kubernetes is actually like a orchestration platform. Orchestration means it's a platform that you can deploy these sort of multiple microservices. See, for an example, you can have like a payment system, payment server. You can have if you take the previous example of the taxi ride application, you can have the payment server, you can have the driver finding server service, you can have a payment service or email service. So all of these services can be developed separately, right? So you can even use different programming languages to develop these each component. So let's say if you have machine learning component, you can use Python to build it. If you have some sort of user management component, you can use JavaScript to build it. So each of these part of these backends can be stored in the as separate backend components, and then you can deploy on top of a single Kubernetes server. It's more like orchestration protocol. Orchestration means, okay, it's a container orchestration protocol that you can. There's a technology called Docker. If you guys want to explore, there's a technology called Docker. It's more like a way of delivering these applications in the most simplest way without having any sort of environmental dependencies. So I would recommend you to check out this application called Docker. It's a really great application to study about if you want to become a cloud engineer in the future. I would recommend learning Docker. It's a great application. So basically, we can deploy these backends as Docker containers on top of Kubernetes, and automatically the scaling parts and automatically the monitoring parts and the connection between multiple services are being handled automatically. So we don't have to really worry about those those aspects. Right. So we have another question. Can any middleman intercept APIs? If so, how to prevent them? Yes, good question. So basically, okay, so I think you are talking about the attacks here. So there can be man of the middle attacks. I know that there are a lot of attacks that are happening. One thing is that you can have really good firewall rules. So with many of these cloud providers, they are providing you with a lot of firewall rules. For an example, if you take AWS, they have a on firewall, and also if you use a protocol like SSL, the secure socket layer with HTTPS enabled, you can actually prevent the man of the middle attacks, because there won't be uh, the whole traffic could be encrypted, so there won't be any sort of man in the middle attacks if you use something like HTTPS, or we can call it as SSL. So that's a great way of doing that. And also, if you use a proper IP standard like IPv6, you can prevent that and make sure you have some sort of a proper firewall rules. And also, if I'm interested, check out there's something called Cloudflare. It's a really great cloud proxy. And if you want to hide your IP addresses, if you want to hide the server's identity, Cloudflare would be one of the greatest choices. If you want to look at, just search for Cloudflare. You will understand what it does basically. Thanks for that question. It's a great important question. Right. Okay. So I guess we are all good to start the second segment. I think that's it for the questions in the first segment. Yeah. So let me proceed further. Yeah. So I think I already explained you all about the benefits of using APIs as simplifying of the complex processes and enhancing user experience and the security. So we discussed about a lot of benefits. I don't think we had to go through these simple points once again, because we already discussed about many points of having these APIs and why we should always go ahead with the 3-tier architecture, which is really important. So yeah. Right. So now let's talk about the frameworks. So I know that most of you all are familiar with Python. So today we are going to look at a sample Python Flask application. to build a sample, a very basic backend application in Python Flask, and to connect a very basic database, as well as to work with some sort of a very simple development. So we'll talk about that, and then we'll talk about some sort of a headless frameworks called Strappy, and we'll talk about Contentful and also Firebase also. So we'll talk about all of these things in very nutshell form within the allocated time period. Right. So we have three frameworks for Python, and there are more frameworks as well. There's something called Python Flask. We have something called Django or Django, and then we have something called Fast API. So if you want to build rapid APIs, if you want to build APIs in very short time, I would recommend using Fast API, which is one of the most easiest way of developing an API, and it's really good. And then for the Java developers, you have something called Spring Boot framework, and there's something called Play framework. So these are the most popular frameworks of API building with Java. And for JavaScript, there's something called Express and Nest.js. So Express is actually introduced a couple of years ago, let's say somewhere like 5, 6 years ago. But right now, the most popular one, the most popular framework for building applications is Nest.js. Even in the industrial standard, we are using Nest.js in our company also. We are using Nest.js to build backends. It's really good, and it's supporting microservices also. So if you want to build microservices in a most advanced way, I would recommend going with Nest.js. That's a really great framework. And for C Sharp, there's something called ASP.NET that is not being used widely, but that's also a great framework for you to try out. Right. So now let's go for the practical assignment. Before that, I think we have one more question. I'll answer that question and I'll go to the practical part basically. Yeah, so we have a question. Learn AKs, EKs, and GKE. And GKE was the easiest and fastest deployment for me. What do you think? Yes, correct. Uh, so I would say, okay, so I don't want to make it very biased here because I don't want to make it very biased here. You know why? There are pros and cons of each of these frameworks. If you take A case, the Azure Kubernetes Service, and if you take the E case, the Amazon's Elastic Kubernetes Service, and GK, the Google one. Um, I would recommend if you are looking at configuring, like, let's say, very complicated user roles, like IAM roles, or maybe, let's say, access delegation for a very large scale organization, I think AWS has the highest edge, right? AWS has the highest flexibility if you want to configure that in the most flexible way. GCP has its own limitations, but GCP is one of the best frameworks, one of the best cloud providers that you all can get things started if you want to easily manage and easily deploy applications. So even at our company, we are mostly using GCP, the Google Cloud Platform, and the Google Kubernetes Engine as well. And also Google has another managed service called Google Cloud Run. If you can find on the GCP console, there's a service called Google Cloud Run. If you want to deploy a Docker application or a containerized application very easily on GCP platform, you can just easily deploy some sort of a application on GCP platform with the size of Cloud Run. In terms of the user experience, I would say, yeah, I would agree with you. GCP is the best in terms of the user experience. But if you're looking at flexibility, I would say AWS has the highest flexibility. And if you're looking at the customer experience, if you want to get an issue resolved, I would say AWS has the best support. Azure has the best support. So all of these frameworks, all of these cloud providers are having different pros and cons. So it depends on the company's priorities when choosing a cloud provider. Yeah, I think there's another question. Why Node.js is not mentioned, right? Let me clarify that. So Node.js, a lot of people are asking about Node.js. So I would say Node.js is more like the grandfather or the godfather of all of these JavaScript-based frameworks. So even if you take a JavaScript-based front-end framework or JavaScript-based back-end framework or something like Nest.js or Express.js, Node.js is the godfather, right? So it's a most high-level parent, the grandfather. Maybe you can say the great grandfather, right? Not the godfather, the great grandfather, basically. So the the most level ancestor. So all of these frameworks are built on top of all of these JS-based frameworks are built on top of Node.js. So if you want to derive as a ancestor, if you want to derive as a child, these are the child frameworks that are there, which has additional capabilities. But these frameworks are inheriting the behaviors of Node.js and then written on top of Node.js. And if you install the Node.js package library, you can definitely work with this. And on top of the Node.js package library, you can install these packages and you can get things started. Right. So here another question. If it is we interest in machine learning side, is learning these API frameworks in Python will help us definitely. So basically, if you are learning about ML side as well, there are so many Python libraries. For an example, Google has their own GenAI SDK called Google GenAI SDK, and that they call LangChain. There's something called LangGraph. So we'll talk about these things. There are so many Python libraries. If you want to talk about it, maybe you can reach out to me on social media and we can have discussion, because there are so many other ML frameworks out there. If you want to become a good ML developer, definitely even these frameworks could be very much useful, because right now when companies are recruiting people, they are looking at your full stack capabilities, not just the domain specific skills, right? They will look at, okay, whether you can build a full scale application. Even if you're a machine learning developer, you have to have that skill set, right? So definitely it's going to help you. So I would recommend using this and studying about these frameworks. Right. So let's continue with the practical part. So I have a small Git repo I have prepared for all of you. So I'm going to share the link in the chat so that all of you can access it. So we have a demonstration repository called, let me share that with everyone. Yeah, I just shared the link with everyone in the chat so you all can access this repository. It's a public repository I have made, and there are so many samples which is given here, right? So I'm going to continue with a few samples, and I'm going to show you some backend operations that can be done with these frameworks, that can be done with this application. Let me go through this first of all, right? So as you can see, if you clone this repository, there's something called starter.py, right? It is the most basic Python Flask application, right? So as you can see, we have something called star.py. And if you open this and if you run it, you can actually run this application completely in a machine. But before that, you have to install Python Flask in your computer. So what you can do is actually, you can search for Python Python Flask install. Just go to Google and search for Python Flask install, and then you will see something like this. You will get to this page called PyPI, and then you can install it as a pip library in your machine. But before you do that, one thing you can do is basically, if you're using VS Code, you can create a virtual environment, or you can just install it directly over here as well. But I would recommend setting up a virtual environment, because we'll be using multiple libraries throughout the entire demonstration. Maybe even if you're building some sort of Python application, if you're having multiple libraries, I would recommend always create some sort of a virtual environment and work on top of that. So you can actually click on this Python version given at the bottom and click on create virtual environment. So after that, choose venv from here, and then choose the interpreter as your preferred Python language. So I'm going to choose Python 3.12, and then it's going to take some time and it's going to create my environment. Right, so now it's all done. So I'm going to go back to my terminal, and then I'm installing this library called Python Flask, and it's going to take a couple of seconds, and yeah, done. So after this, let me install that again. Yeah, it's going to install in my environment. So after that, what you can do is you can just run this application as a Python application. So what you can do is you can just type the Python command starter.py. So once you do that, it's going to run this application as a Flask server. So now let's try to understand what it does, right? So we did something blindly now. We just install some dependencies. We just install something called Python Flask. I know that some of you all might be confused on what we did here, especially the beginners who are new here. I know that you all might be confused on what we did here basically. Why did we install something called Python Flask, and how did we run this server? Right. So one thing is that when it comes to the Python language, there are certain capabilities, right? There are certain capabilities where we can, with the language by default, it comes. There are so many capabilities, but there are something that are not possible with the language also. So that is why we have something called library management, which allows us to add additional capabilities to Python, right? So for an example, if you guys are looking at adding different capabilities to your Python language, there's something called Python library, Python PyPI, which is known as the Python package registry. So what you can do is it's more like a library of different Python packages. It's more like a community of developers, right? So if you are a developer, if you want to introduce a new skill for Python, if you want to introduce a new capability for Python, you can do that from here itself, right? So all what you do is basically you can just create an account and then you can build your own library and you can publish so that other developers can use it and they can get benefits, right? So that is the whole point of having this library itself. And then I added a new capability to Python to be able to work as a server. So if you want to let Python to work as a server, there are so many ways. One thing is that you can install Python Flask. Another way is you can install something like Python Fast API, or you can use something like Python Django. So all of these things are Python frameworks to build a web server. But here I'm using Python Flask. That's why I use this command pip install Flask to install Python Flask. Right. So now you can see, if you look at the code very carefully, you can see there are two functions. There's something called read items and there's something called post items. Post means, okay, just to create something. Read means to get some information, right? But you can change this method in the way you want it, right? So if you use meaningful methods, that's you are the one who's going to be benefited. But here you can see there's something called get method and here there's something called post method. So altogether, as you can see, there are two API endpoints. So now let me run this program once again and show you something. So if I run this program, you can see it gives me a URL like this. It says HTTP 127.0.0.1:5000. This is called the base URL, right? This is called the base URL of the backend service, right? And then these are the endpoints. So basically, if you want to call this endpoint, if you want to read the items, and if you want to call this read items function, what you can do is you can use this base URL and you can have a slash and items and you can call it, right? But how do we test these endpoints? There has to be a way to make that request, right? So for this particular purpose, we have a special software called Postman, right? There's a special software called Postman that all of you can use to uh, like optimize the request testing as well as to make this request and to test anything. It's a great software that all of you can use. If you just go to Google and find Postman, you can actually find it over here. It's one of the best softwares that you all can use to test these APIs, and it's there for all the systems for Windows, Mac, and Linux. It's there, so you can just go to this website and you can download it from here. And it's a really great software that you all can use to test these applications and test these APIs. So I already have this. So what I'm trying to do is basically I'm going to create a new request and I'm going to test one of my APIs. Because I have, as you can see, there are two APIs over here, something called items, get items, and there's another one called post items, right? So I'm going to first of all try this endpoint called get items, and then let me see how I can do it, right? So I'm going to copy this base URL and then paste it over here, right? So if you try to make a request, you will see something called 404 not found because that's not a valid URL I'm trying, right? The base URL has to be slash items. So I'm going to copy and paste this slash items thing and paste it over here. And the method is get. And here also the method is get. And I should get the items correctly, right? So as you can see, now it says hello world. Why? I'm straight away calling this function, right? So because of that, you can see the output is given as a JSON output, right? So like I mentioned, JSON is the universal language that we're using to communicate between front ends and the back ends. So because of that, you can see the JSON output has been given right over here. And we had the capability of giving a JSON input also, right? Not just the output, we had the capability of giving a JSON input also as the request body. That is also a capability. So we don't have to worry about, having different types of data, because with JSON we can obviously, you can like provide dynamic inputs, so that sort of operations are possible with JSON. So I would recommend just trying out with this repository is really good, right? So now what if I change this method type to something else? So let me try post. So I'm trying a post items request now. So now you can see it gives me error saying 405 method not allowed. What is the reason? So in my backend, I don't have an endpoint call items, which has the method of post, right? So you can see the items is only supporting this method called get, right? So I'm only allowing the user to get items. So because of that, I don't have any sort of a post items endpoint in my code, right? There's no post items endpoint, but this is different, right? So we'll check this out later as well. So you can see if I say slash items, there's no separate endpoint to post items. So because of that, I'm saying I'm getting this error called 40 found method not allowed. And then if I try this endpoint, it says slash post. So I'm going to try this endpoint also. So now let's see what sort of thing I would get. Okay, so I'm trying with post method. So now you can see it says this is a post method, and you can see it's correctly calling that, and you're getting this sort of a response from my backend. And if I try to change this into get method, you can see still I'm getting that error saying method not allowed 405, just like that. So we had to properly give the input, and we had to go with the correct method and the correct method, the correct endpoint and the correct method type. So it depends on that only we would get the output. So here in this body, you can actually define your logic, Python logic. For an example, if you want to add item to a list, to read some items, to get some data, right? So you can write your own logic here. You can even talk to databases. You can implement a MySQL behavior, right? So all of these things can be done as part of the function body. You can define your own logic and you can easily get it done. So yeah, you can do that very easily. So I hope you all had a brief understanding. So let's go for another example. So I'm pretty sure after this example, you guys will have an understanding on how practically this can be applied. And then let's see how we can implement this to a front end as well. So especially when you're developing a mobile application, it can be used to, talk to add capabilities. Let's see. So now we have another file called crud.py. This is actually a real world example, real world scenario of how we can actually implement a CRUD based application. CRUD means we are creating an item, we are adding an item, we are adding an item, we are getting the items, and we are updating, deleting, right? So all of these operations are possible with this file called crud.py, right? So as you can see, this is my endpoint one. You can see there's something called items, which has the method type of post, and it would create a new item, right? And as you can see in the top, we have an array called items array. It's a list actually. So what happens is basically is when someone calls my endpoint of items, with the method type of post, it's going to add a new item to my items list, right? And as you can see here, basically, I'm taking some parameters as the inputs also. As you can see, I'm taking the name and the description as inputs from the user. So the user can actually pass these inputs from the postman, and then we would collect it from the backend, and we would execute the logic. And then at the end, we would send the response of the user back to user whenever the item is created. And then we have another function called, we have another endpoint called read items. So if you want to get all the items that has been added to the database, you can straight away call this read items function and then get all the items as a list, and then you can easily fetch all the items. And then you have another function called read item. So if you want to get a specific item from the list, like by passing the ID, you can call this very easily, right? And then what it does is basically it's going to look at the items array, and then it's going to pass whatever the item that matches it. And then we have another function called update item, and then we have another one called delete, right? So you can see there are so many operations that are possible with this code. So let me run this file. So I'm going to run this file called crud.py, and let's see what happens. So now you can see my service running again. And then I'm going to first of all try this first function and see what's going to happen, right? Okay, so we have function called items post, right? So I'm going to try this endpoint. So I'm going to copy and paste this items endpoint to here. And then I'm going to keep my method type as post. And then I'm going to send the request. Yeah, so now you can see it crashed, right? The request has been crashed. And then there has to be a reason why. You know why? Basically, as you can see in the post endpoint, there are two inputs. So we have two inputs. As you can see, we have to pass the name and we have to pass the description. So how can we pass it? So we can actually go to this section called body in Postman, and we can go to set this option called row, right? So in the row option, we can actually choose this type to JSON, and then we can start a JSON body like this. So see, when you're providing the input, we have to make sure how the backend has been created. So maybe we can refer to the backend code and understand how the backend has been done and what are the inputs the backend is expecting. And output, obviously, we can see, we can obviously see the output, but when you're providing the input as a JSON, we should dig into the backend code and see what sort of inputs are they taking, right? So as you can see, there are two inputs, the name and the description. So I'm going to put the name and the description here as the input. And let's see, for the description, I'm going to put something like, let's say, I'll keep it as test, and then we can call it, right? So now you can see output says 201 created, and then you can see this data has been added to my list now. So if I keep calling this multiple times, you can see it's keep getting added, and you can see this ID is getting incremented because you can keep on adding items to my list. So that is possible. And then you can see in this example, we have given an input and then we are getting the output also. So the second endpoint is that getting all the items, right? So if you call this endpoint called items as a get, we should be able to see all the items that are part of the list. Let's see that. So now you can see, right, the moment I call this get endpoint, it's going to retrieve all the items that are part of my list, because previously I called this endpoint, I called the post endpoint 3 times, and now you can see this has been added to my endpoint 3 times, sorry, my list 3 times, and it's showing the data just like this, right? There are 3 objects, and you can see the description and the name and the ID. So all of these things are being returned from my endpoint of reading all items, which is this endpoint. And then we have another endpoint called items get item by ID. See, all what we do is basically just have a slash over here, and then pass ID. See, for an example, if I pass the ID like 2, you can see it's retrieving the item of 2 along with all the information. So you can get this information by just passing the item ID 2 and get the data. And then you have another endpoint called update. So if you want to update any information, what you can do is basically you can set this method to put right from here, and then you can change any information. See, and one thing is that the item ID has to be present in the URL based on this format we have defined here. So it's all about how we look at the backend structure, and how do we call this endpoint from my Postman itself. So first of all, we should look at the structure the backend is expecting, and based on that only, we should decide how to provide that input from my Postman. So that is number 2, right? So now if I decide to change something, I can just put a different name, update it. So now you can see the item number 2 has been updated. And if I call back the all endpoint, you can, if I call back the all items endpoint, you can see that the second item has been updated with a different name. And just like that, you can see all the items are there and then given in a structured way. So now you can see the JSON input. So we were using JSON input as well as you were using JSON output. And you can see based on this, JSON input and JSON output both are given. And very easily, we can structure this. Right. So before we move forward, can I see if there's any questions up to this point, any unclear parts, in any uncertainties you all have? I'm free to clarify those things before we move forward. You all can use the chat to ask any questions. So I'll give like 2-3 minutes for you all to drop your questions here. All right. So seems like so far no questions up to this point. Yeah. Anyway, feel free to use the chat section if there's any question. I can answer while conducting. So no worries, take your time and drop your questions in the chat. So yeah. Um, okay, I think just give me a second. How can I clear this? Right. Okay. So let's move forward. One thing is that, okay, so now we have actually studied how we can build a basic level API as well as how we can perform some sort of CRUD operations to create some resource, to delete some resource, add some resource, and to work with different types of CRUD operations. We looked at that, and also we worked with the Postman software to test some endpoints. So that is also there. So yeah, so now what we are going to look at basically, so now I know that you all have a question. Now we have built an application, and how do we integrate this backend with my front end? So I think that's a question that all of you are having. So let me show you a trick, a code trick that is being given on Postman. So in Postman, if you use Postman, there are so many advantages. As you can see in Postman, there's something called code mode, right? So if you go to the very right top corner, you can see there's a code icon over here, right? And you should be able to pick any programming language from here. So if you're using Flutter to build your application, to build your mobile application, you can just choose Dart from here. And it will give you the code that you can use to integrate this sort of a application with this sort of a backend with your Flutter application, right? So just a matter of copying and pasting this code, you can actually, have a very basic integration with your Flutter application. So let's say if you are using something like let's say React Native to build your application. So what you can do is you can just choose Axios from here. If you're building React Native application, you can choose Axios because Axios is a powerful library to make API calls. So let me show you that also. If you search for Axios, it's a very powerful library to make HTTP requests on any framework for Node.js, for React Native or any other frameworks. Also, Axios is supported. So just a matter of choosing Axios from here. And then if you're using any sort of like Java-based programming language, you can pick Java from here and you can actually generate the code very easily. And then just a matter of changing these values, right? So you can see these, there are different values as part of the body. So just a matter of, changing these values and sending it to the server. So that makes much more easier for you all to update these values and make HTTP call. And let me show you one more tool, one more interesting tool that all of you can use. So I know that working with these sort of outputs can be very challenging, right? Because we had to read these values in your front end. So there's an interesting tool called QuickType that I always use. Um, if you want to build JSON structures, and if you want to build, structured code based on JSON data, right? See, for an example, let's say if you're using Dart, you might have to build the data modeling, right? You might have to build the data models, or you might have to build the whatever the data pipeline. So in that case, QuickType offers you like a very visual type of a UI that you can easily get things done. I think right now it seems like it's down at the moment, but usually it's like interface like this. So what you can do is you can just copy and paste your JSON data right over here, and then it would export it in whatever the format you wanted. You can choose your favorite programming language, whether if it's Dart, whether if it's JS. Based on that, the representation will be done as a model. So I would recommend using QuickTime. It's a really great application that all of you can try out if you want to easily build like data modeling for any language that you wanted. But unfortunately, seems like it's down at the moment. But later on, just give it a try later on. Definitely, it will work for you. So yeah, that is also a great tool that I can address. Right. So next part is that database connection. So I know that we had done multiple things. We studied about the CRUD operations and how to build a basic application. So apart from this, I have given another sample in my code base called database.py. So if you want to link some sort of MySQL database or a Postgres application to your application, you can actually use this thing called Flask MySQL connector. Sorry, the Python MySQL connector. That is also a great toolkit that you can use to connect your Python application with MySQL databases. As you can see, as part of the DB config, you can provide all the MySQL credentials, like just like the password, username, hostname, and port, and every single configuration you can provide over here. And this is a sample application that creates a users table, and you can add users and you can delete users, and sorry, you can add users, and also you can list all the users from the database, right? So as you can see, this has the MySQL connection already, and we have the usernames, we have the passwords, we have host names, port, database, and every single thing is configured over here. And we have two endpoints. First endpoint is called the get users endpoint. The second one is called the add user, right? So as you can see, as part of my get user endpoint, I'm doing a query over here. As you can see, it says cursor.execute, select all from users, right? So you can write your favorite MySQL query. If you want to write any sort of MySQL, if you want to use any sort of MySQL queries, you can write it over here and read data just like this. And my second endpoint is called add user. And you can see here also, the moment I get all the users data as JSON input, you can see I'm calling this MySQL query call insert into users and name and email, and then adding these values straight away to my database, right? So just like this, I have two endpoints and it's talking to my MySQL database. And the moment I capture the data from my Postman or the front end, it's going to create a MySQL, it's going to create an entity on my database, right? And then I can get the database, get the information as well very easily. That is also completely possible. So I'm going to show you a live demo of this. So let me first of all show you my database. And as you can see, I have a database called Flask, and then I have table called users. Let me clear this table just to before I show you all anything. So I don't have any users right here. So I'm going to show you a small demonstration, and you can see in the data in my database, there are two columns, which is the name column and the email column. And I'm going to run my database.py file, and I'm going to show you how to get this working. Right. So let me start this program once again. So I'm going to run this file called database.py. And now you can see it gives me error saying module not found, no module name called MySQL. So I have to install this. So I'm going to run this pip command to install my MySQL connector. So like I mentioned before, if you want to connect a MySQL database to your Python application, this thing, the MySQL connector for Python is the best choice that you all can look at, and you can easily install this as a library and you can get working. And then I'm going to start this once again, and you can see there's another module which is missing. So I'm going to install this module called Flask Host as well, which is required to run my application. So I'm going to install this also, and then let's try to restart it again and test it. Right, so I'm going to kill my other application, and then I'm going to restart this. Right, just a second. Right, so now my application is running on port number 5000, and I'm going to add a new user now, right? So what I'm trying to do is I'm trying to locate my add user endpoint, which is this, and I'm calling this endpoint called user, and I'm going to pass these two values, which is the name and the email, right? So I'm going to pass the name just like this, and also the email address. And then I'm going to call a post endpoint. As you can see, it's a post call. It's a post method. So I'm going to call a post. I'm going to make a post request, send, and now you can see the user has been added, right? So if I go to my MySQL database, you should be able to see the user, right? So you can see the newly added user is right here. So if I want to make any change, I can just go back to this and I can add a new user as well. So let me add a new user here. So I'll add something called hello. Now just say test user, send, and you can see the user is there. The second user is also there in my database. Just like that, I can have a simple MySQL connection between my database and the backend. And also the moment you call the front end, so the moment you call the backend service from your front end itself, automatically the user adding part to database can be handled from the front end towards the backend. So that can be automated. So I have a sample source code for that also. So if you want to refer to, there's a sample file I have given. There's something called sample.py that I'm going to run now. So let's see how that works. So you can see there's something called sample.html. So if you right click and inspect, you can see there are two buttons. There's something called click me to add a new user. There's another button called fetch data to get all the users basically. So if you want to add a new user, you can just click on this button called click me. And then if you go back to your database, you can see there's a new user added to the database because I'm calling the backend endpoint straight away from my front end. And if I want to get all the users, I'm going to call this button called fetch data. So you can see all the data which is there in the database are being fetched from the front end. So let's see how that has been done. So as you can see, I'm using this library called Axios to make all the HTTP requests from my front end. And you can see there are two functions, the fetch data function and the button click function that adds the data, adds the user through my backend. And then the moment I call this fetch data function, it's going to call this endpoint call get users and retrieve all the users from my backend. And it's going to show all the data in my web page, right? So basically, it's more like a get function I'm performing from this fetch data function. And then as a second function, I have the button clicked, which is to add some data to the backend. And straight away, the moment you click the button, automatically it's going to add the user's data to the backend. So that's how it's going to work, right? So as you can see, it's a sample.html file. So you can find this file in my sample source code I have given. So you can go through it and try to understand. So maybe you guys can use a Copilot to understand every single code line because we have a limited time. So I have to stick to the timeline and go to the other aspects as well. So anyway, that is the basic of how we can write a simple API and how we can call it from the front end. So regardless of whether you use HTML, React, Flutter, or any sort of other framework, we can easily get things started. We can easily build an application and the integration can be done seamlessly if you use Postman, because Postman has this capability of, generating code just like this. Very easily you can get it done with the support of Postman. All right, so let's move forward now. So now I want to talk about some, so now I know that it was a bit technically challenging as well, but let me show you some interesting products that are there that you can easily build some backends as well as easily integrate with your applications also. This is Firebase, right? So Firebase is a service from Google. If you want to build applications rapidly, Firebase would be a great choice. But for production scale, for production use, I would not recommend, like I mentioned before, for production use, I would not recommend directly integrating Firebase database with your mobile application because there wouldn't be a logical layer, right? But if you're looking at building a prototype for a hackathon or for a competition, Firebase database would be a shortcut to easily use and easily build a backend. And that sort of operation, Firebase database can be used. So as you can see, we have a option called Firestore database in Firebase. So you can easily use this and you can store any of your data on Firebase very easily. That's also there. And let's say if you guys are building some sort of a real-time application, maybe an application to store any sort of real-time content, maybe let's say a score, or let's say some sort of result or some sort of any other parameter, right? Firebase has something called real-time database that all of you could use to store real-time data. It's a really great database tool that all of you could use to store real-time information. And also as part of the Firebase framework, they have so many other facilities. For an example, let's say if you want to have some sort of a Google sign in or some sort of mobile phone sign in kind of things, right? Login with Google or login with Facebook, login with Apple. So these sort of operations are also supported with Firebase authentication. So if you want to have some sort of passwordless login, Firebase is the go-to option that all of you can try out. And also, if you want to add some sort of a real-time analytics, let's say if you want to see the number of users who are using this application, Firebase has something called analytics dashboard that you all can try and you all can see the regions of the users who are using your application. That is also a great place to see all the application insights in one place. And yeah, so all of these things are there. And also there are AI capabilities also with Firebase. There's something called machine learning. So if you want to integrate any sort of machine learning models or any sort of generative AI kind of capabilities, Firebase has a place for that also. And there are so many capabilities. Just feel free to reach out to me if you want to understand what sort of other capabilities are there with Firebase. That is there. And as an alternative to Firebase, if someone is not interested in using Firebase, there's another one called Superbase actually. Superbase is actually an alternative to Firebase. That's also a really great thing. So they offer you a Postgres kind of database for anyone to store data. So as you can see, there's a SQL editor right over here. And then if you want to add any sort of databases, you can use this database to create your favorite Postgres database. That's also a great platform. And similar to Firebase, they have authentication, they have storage, and they have multiple other services also that you all can try out when you're configuring your applications. The best part is that both of these Firebase and Superbase, they are supporting all of these mobile frameworks. They have their own SDKs. If you want to have some sort of integration with your application, just go to Google and search for Firebase Flutter SDK, or you can just search for Superbase Flutter SDK. They have any sort of integration for Flutter for Android, iOS, and web as well. So regardless of whether you use Flutter, if you use React Native, they are supporting any integration, so you don't have to worry about that. These things are supported for any integration, so that is well in place. And even if you take Superbase for integration, they are also having Flutter integration. So as you can see, they have the Flutter integration, they have Flutter SDK. And even if you're using some sort of other framework like React or React Native or iOS, Kotlin, or any sort of mobile framework, they have their own SDK that you can integrate with their databases and get their service very easily. So that's also supported. So you all can just give it a try and see. Right. So now we are at the end of the session, but I have one more session, one more interesting framework to show you all. It's called Strapi, right? Can I see a raise of hands? Anyone who have heard about Strapi by any chance? Okay, there's no one. Right. So basically, I know we discuss about so many things today, right? We from MySQL to APIs, sorry, from APIs to MySQL to architectures to Firebase to Superbase. I know it's too much of information within the day, but let me show you an easy way to build a backend for your application, right? So we discuss very lot of technical things, from fundamentals to integration to Flutter, sorry, to Flask to multiple things to Postman. There are so much of information. I completely understand that. So in the industry, or when you're building application, there could be instances where you want to build your own admin dashboard, right? And to cater the information as API, right? See, for an example, let's say if you are building some sort of news application. So if you're building a news application, you definitely need a dashboard, a place to upload the information, place to upload content, articles, images, right? So Strapi is actually called as a headless CMS, where you can set it up within few seconds, right? And the best thing is that they are offering you an API so that you can have an integration with the application, and you can easily change the content of this application while providing a user-friendly interface. So this interface, you don't have to code it, right? Automatically, the interface is there. The moment you install this Strapi in your application, in your server, the interface will be there. So just a matter of structuring that based on your content, and you can build a very easy backend with Strapi. So let me show you how it can be done, right? So if you go to Strapi documentation, you can see there's a command like this, right? So if you go to the website, there's something called npx create Strapi. You can just copy this, go back to your terminal, and let me show you a quick demo and then we can go to the questions right after that. So I'll just go to my desktop and I'll create a folder, Strappy. I'm going to run this command, right here. And then yes, and it's going to install some of the dependencies. And let's see how quickly we can get the admin panel done and dusted within a couple of seconds itself, right? So yeah, let me see. Yeah, just give me a second. So I might have to clear some of my content. Seems like I'm running out of my storage. So just give me a second until I clear that up. So right after you clear your storage, you should be able to easily install this Strappy dashboard. And then yeah, you can just give me a second. Let me clear my storage very quickly. Then I'll come back to that. Just give me a second. All right, let me try the command once again. Hopefully that works this time. Hopefully my storage will be gone by then. Let me try this command once again. So then we can install and see. Yeah. Right. So unfortunately, seems like it's still taking some time, but anyway, that's fine. Unfortunately, due to the time constraint, can't wait for longer. And let me see one last time. Yeah. Yeah, sorry, really sorry about that. But by the way, once you configure that, you will see a interface like this. And as you can see, we can actually add custom components, right? We can add text components, we can add descriptions, we can add text fields, right? Just like this, we can configure the layout in the way we wanted, basically. And then at the end, once you configure this, you will get an API, right? Just like this. You will get REST API, and automatically you can interact with your application, whether if it's Android, whether if it's something to do with Flutter or React Native or any other framework. We can easily integrate with your own data with your API. So you don't have to worry about building this sort of a layout because um, of a dashboard, because automatically you can configure the layout that you wanted based on the fields that you setting up. So um, that's sort of in a simplified way, you can get it very easily set up. So you don't have to worry about that. And you can give it a try. And there's another one called Contentful. That's also something similar to Strappy. If you want to create admin dashboard and the API very easily without having some sort of development effort, you can try both, which is the Contentful and the Strappy both, which are really good. So you can just give it a try and see. Both are same. But interfaces are different. Yeah, so I would recommend you all trying it out. So later on, you can use it for multiple purposes. With that being said, I think we can wrap it up, and we can open for questions now. And thanks for staying for 2 hours. Thank you. Right, so we have a question. What is PHP Good question. So basically, for beginners, let me quickly explain you all what is PHP. It's more like a user-friendly UI that you all can use to manage databases of MySQL, right? So it's a place that you can add data to MySQL databases in a visual way, right? Rather than running MySQL queries in your server, if you want to add data in a visually appealing way, in a visual data interface, you can use PHP as a front end medium to add your data. We use PHP via that dashboard. So it's a open source one. So if you want to set it up in your local machine, you can install either WAMP server or XAMPP server, WAMP or XAMPP. Once you do that, automatically that comes to your machine as a service. Any more questions? Right. So if there's any questions, feel free to use the chat, or you can drop me a direct message on social media. That's also possible. Yeah, happy to answer any question that you all are facing, anything to do with backend development, anything to do with databases or cloud. Feel free to talk to me. I can just clarify any doubts for you all. Right. Okay. If there's no more questions, we can wrap it up and over to the organizing committee to continue. Thank you.
Thank you so much, sir, for that amazing and insightful session and for addressing all these questions earlier. That was really valuable. And now we will move straight into closing part. Organizing team, I would like to sincerely thank Mr. Shanti Travels and our official digital media partner for their continuous support. Sorry, I got a network issue. Uh, I will continue now. A special thank you goes to our knowledge partner, Articom, official banner partner, Shanti Travels, and our official digital media partner, Hackasel, for their continuous support. Before we wrap up, a big thank you to all our participants for joining today's session. We really appreciate your enthusiasm and engagement throughout. Before you leave, please scan the QR code shown on the slide to join our WhatsApp group and stay updated about upcoming sessions and event details. And of course, our heartfelt appreciation to the organizing team for their effort and commitment in making this session a success. That is all from us for tonight. Thank you. Thank you once again for being with us. And we look forward to seeing you in our upcoming sessions. Have a wonderful evening, everyone.